Hello, grade 12s. Welcome to Academic World by Mpatele TL. Today I want us to talk about the geometric sequence. Remember, we spoke about the arithmetic sequence. Now, in today's lesson, we are focusing on geometric sequence. So we should be able to find the general term of a geometric sequence. That's the first thing that we are going to look at. Without waste of time, let's look at that. So let's say we've got the sequence 8, 4, 2. So you are given three terms of the sequence. And what does the question want? They are saying determine nth term. So determine the nth term. They are looking for the general term. So let's solve this problem. Determine the general term of this sequence, 8, 4, 2. So the first thing that I said, if you can recall, even when we were dealing with arithmetic sequence, I said you must first identify the type of the sequence. You must identify the type of sequence. Whether you are dealing with a geometric, arithmetic, or quadratic, you must identify the type of the sequence. So this one, we see that it's a geometric sequence. How do we know? If we take term 2 and divide term 1, which is 4 divided by 8, it's 1 over 2. And when we take term 3, divide term 2, which is 2 over 4, we are also getting 1 over 2. This is what we call the common ratio. This is what we call the common ratio. So, common ratio. The geometric sequence, all geometric sequence, they have got a common ratio. Geometric sequence are identified by the common ratio. So, which means that every time in a geometric sequence, when you take term 2 and divide term 1, you should get the same answer when you take term 3 and divide term 2. This is how we see that the sequence is geometric. We identify the geometric sequence by the common ratio. All geometric sequence have got the common ratio. You take term 2, you divide by term 1. If you get the same answer, when you take term 3 and divide by term 2, you know that the sequence is geometric. In this case, term 2 was 4, term 1, 8, term 3 is 2, term 2, it's 4. So since we have got the same ratio, the sequence is geometric. Now, how do we find the general term or the nth term of the geometric sequence? You use this formula. You say Tn equals to a r to the exponent n minus 1. So we're going to say T of n, a is the first term of the sequence. So you look at your sequence 8, 4, 2, which value appears first? It's 8. So this is your first term of your sequence, 8. And what is your ratio? The common ratio, it's 1 over 2. We calculated the common ratio. We saw that it's 1 over 2. Then you say n minus 1. So this is your general term. Tn equals to 8, 1 over 2 to the exponent n minus 1. But you can notice that in this case, watch out, grade 12, don't do this. Don't multiply 8 with 1 over 2 and claim that your answer is 4 to the exponent n minus 1. That will be a wrong algebra. Don't say 8 times 1 over 2 is 4. Some student in this case, they can be tempted to multiply 8 with 1 over 2 and say 8 times 1 over 2 is 4. That will be wrong. Now, I will show you the approach. I will show you what you can do if you really want to multiply this 2, 8 and 1 over 2, there is something that we have to do first. What we can do, we can say, okay, 8 can be written as 2 to the exponent 3. And 1 over 2 can be written as 2 to the exponent negative 1. You can check it even on your calculator and say 2 to the exponent negative 1. You realize that it's 1 over 2. Then here you are saying n minus 1. Therefore, Tn equals to 2 to the exponent 3, 2 to the exponent, I will multiply these guys here. This negative 1, I will multiply it with n. I'm applying distributive law. Negative 1 times n, it's a negative n. Negative 1 times negative 1, it's positive 1. So now, yes, you can say, let me take it and write here. Now you can say Tn equals to, you see that you are dealing with the exponential expression. You are multiplying powers of the same base. If you look at this power here, 2 to the exponent 3, which is being multiplied with this power, 2 to the exponent negative n plus 1. You notice that the base is the same. Our base is 2. So your answer is going to be 2. When you multiply powers of the same base, you keep the base and add the exponent. So you're going to have 3 being added with this one. It's 4. I'm adding the exponent. So I'm going to have 2 to the exponent 4 minus n. So this is the general term of the geometric sequence 8, 4, 2. So hopefully you guys will be able to find the general term of a geometric sequence. Okay. Okay. For now, we talked about finding the general term of a geometric sequence. So let me erase. Okay, let me erase all this stuff here. I found the general term of the geometric sequence 842. Let me write this general term somewhere here. Tn equals to 2 to the exponent 4 minus n. This is my general term. The general term of the geometric sequence 842. So I want to bring this question now. I want to say find term number. Let me say find term number 6. How are you going to find term number 6? You are looking for T6. When we say find term number 6, it means you are looking for the number which lies on position 6. So you are looking for term number 6. So you're going to do this. You're going to say T of, where there is n, you put 6 because you are looking for term number 6. So you say, okay, you substitute your n with 6, 4, you subtract 6. So term number 6 is the same, is 2 to the exponent negative 2, because 4 minus 6 is negative 2. So it's 2 to the exponent negative 2, which when you press it on your calculator, it's 1 over 4. So term number 6, it's 1 over 4. Okay. Another question that I can bring now, I will say, let me say to you guys, this sequence is continuing. So I will have 1 over 2, 1 over 4, 1 over 8, 1 over 16, 1 over 32. Let me write 1 over 32 here. So now you know that the sequence is continuing. You have got the sequence 8. Now, on the first term, we have got 8. On the second term, we have got 4. On the third term, we have got 2, and the sequence is continuing. On term number 4, we have got something. On term number 5, we have got something. The sequence is continuing. Now the question is, which term is the value 1 over 32? We want to know this number 1 over 32 is on which term, is on which position. You can see clearly that 4 is on position 2, is on term 2. But we want to know this time around which term is the value 1 over 32. 1 over 32 is found on which position. So what you do now, you say Tn equals to, you use your general term. Hopefully you still remember that our general term, it is 2 to the exponent 4 minus n. So you use your general term to find on which position it's 1 over 32. So you are looking for n. You come to this Tn, you substitute it with 1 over 32. So you say 1 over 32 equals to 2 to the exponent 4 minus n. Now, you are dealing with exponential equation where on the right side, you have got the base of 2. If you look on the right side of your equation, you've got the base of 2. So you have to express 1 over 32 as well somehow as a base of 2 so that you can have the same base. The base on the right, you try to make the base on the right to be the same as the base on the left. So 1 over 32, can we express it as a base of 2? Can we say 1 over 32 is 2 to the exponent something? I want to try that, which is going to be equals to 2 to the exponent 4 minus n. So I want this, guys. I want the base to be the same. So I have to find a way of writing 1 over 32 as 2 to the exponent something. So what is 1 over 32? Let me deal with it here. 1 over 32, I know that 1 over 32 is the same as 1 over, you might realize that 32 is 2 to the exponent something. What can it be? Can it be 2 to the exponent 4? Let's check. 2 times 2, it's 4, times 8, it's 16. 2 times 2, it's 4, times 2, it's 8, times 2 is 16. So actually 32 is 2 to the exponent 5. Confirm it on a calculator. 2 times 2, 4, times 2, 8, times 2, 16, times 2, 32. So 1 over 32 is the same as 1 over 2 to the exponent 5. And 1, you can, 1 over 2 to the exponent, which is 1 over 2 to the exponent 5 is the same as 2 to the exponent negative 5. Is the same as 2 to the exponent. You can check it on your calculator and say 2 to the exponent negative 5. You'll realize that actually 2 to the exponent negative 5, it's 1 over 32. So now I have the same base. So I can equate the exponent. I'll say negative 5 equals to 4 minus n. You see that I'm focusing on the exponent. I'm focusing on these guys here. So I'm saying negative 5 equals to 4 minus n. Group like terms, take 4 to this side. So it's going to be minus 5 minus 4 equals to minus n, which is minus 9 equals to minus n. Therefore, n is 9. You multiply both sides by negative. So you can see that 1 over 32, it's found on term number 9. The question was saying, which term is the value 1 over 32? So we conclude by saying 1 over 32 is on term number 9. So Practice makes perfect, guys. Go and look at geometric sequence. How can you find the general term of a geometric sequence? How can you find the term number of a geometric sequence? How can you find the position of a value on a geometric sequence? So practice makes perfect. Go and look at this topic of geometric sequence. Thank you for visiting my YouTube channel. I will see you next time.